Hello, welcome to my channel. Here I do problems in physics and chemistry. If you like my content, please like and subscribe, as well as check information below this video about tutoring in these subjects that I provide. In this video I'm going to do a problem about chemical equilibrium. Some solid NH4HS is placed in a sealed and evacuated 250 ml flask at 298 Kelvin, and the above decomposition reaction is allowed to reach equilibrium. NH4HS solid makes H2S gas plus NH3 gas. At 298 Kelvin, Kc is the equilibrium constant, and delta H is the enthalpy change of the reaction. Calculate the concentration of the NH3 gas at equilibrium. Okay, so to calculate this concentration, we can use the equilibrium constant. The equilibrium constant here, Kc, equals 9.0 times 10 to negative 2. Now, this constant equals to the product of the concentrations of the products of the reaction to the power of their coefficients. However, here coefficients are 1, so we just have a product of concentrations. Here you would also divide by the reactants. However, reactant here is a solid chemical, and if anything is a pure solid or liquid, it doesn't go in the expression for the concentration, for the equilibrium constant. So we don't have it here. So all we have here is the product of these concentrations, and this equals to 9.0 times 10 to negative 2 at equilibrium. Now, also these concentrations at equilibrium will be equal, because in the reaction these two chemicals are produced at 1-to-1 ratio, so their concentrations will be equal. So we can simply replace both of these with one letter. Let's say we replace it with x. So now we have x times x, which is x squared, equals 9.0 times 10 to negative second. So x equals, take a square root, 3.0 times 10 to negative 1. The answer is B. Next question. If some additional NH3 gas is injected into the flask, which of the following options correctly predicts the reaction shift, and what would happen to the concentration of NH4HS? So we are dumping NH3 gas, this chemical, into the reaction. According to the Le Chatelier principle, when system is disturbed, it will change in the direction which decreases the disturbance. The disturbance here is extra NH3. So the system will change to decrease the NH3. How do you decrease NH3? You consume it. You run the reaction in this direction to the left to consume the extra NH3 and to reach the new equilibrium. So here the reaction will shift to the left, and as a result of that, the amount of NH4HS will increase. You will make extra NH4HS. So the correct answer here is A. If the temperature of the flask were to be increased to 313 Kelvin, which of the following identifies what would happen to the amount of NH4HS present at equilibrium and correctly explains why? So increasing temperature from 298 to 313, what would happen? Okay, so the same principle. When the system is disturbed, it will change in the direction to decrease the disturbance. Here we are increasing temperature. We are heating it up, giving it extra heat. Now, to answer this question, we have to look at the enthalpy change, delta H. Is heat being produced or absorbed in the reaction? And this relates to the forward direction. So when reaction runs to the right in the forward direction, the heat is consumed. When the enthalpy change is positive, it means that the enthalpy of the products is higher than the enthalpy of the reactants. So heat has to be consumed in the reaction. 91 kilojoule per mole of the reaction will be consumed. So if we're transferring heat into the reaction, it will run in the direction to consume this heat. And according to this enthalpy change, this direction will be to the right. It will consume heat when it runs in the forward direction. And as a result of that, it will consume the NH4HS. So what will happen to NH4HS? It should decrease. Okay? It should decrease. And it will decrease because the value for the equilibrium constant is going to change. Okay? It's not because something is becoming more disordered. It's because the change in temperature will actually change the equilibrium constant. And here it's going to increase it because when the reaction runs forward, it consumes heat energy. Okay, and the last question. If the reaction were to be repeated at 298 K using the same initial amount of NH4HS, but in a 500 milliliter flask, what would happen that affect the concentration? How would that affect the concentration of NH3 at equilibrium compared to the trial at 250 milliliter flask? So doing everything the same, but in a bigger volume, in 500 milliliter flask. Okay, so here you're producing gases in the reaction. The temperature is the same. It didn't change, so the equilibrium constant has to be the same. It didn't change. It's not going to change. Okay? What will change now, if the equilibrium constant stays the same, remember the product of the concentrations will stay the same at equilibrium of H2S and NH3. What will change, however, is you will need to reach the same concentrations of these two chemicals. You're going to need to produce more of these chemicals, for a bigger volume of the flask. You're going to need twice as many moles of these to fill up twice as bigger volume. So as a result of that, you're going to consume NH4HS. So what's going to happen to the concentration of NH3 at the new equilibrium? Well, the equilibrium will have the same concentrations. It's not going to change. The only thing is that you're going to produce more of these to fill up that volume. So the correct answer here is it would be unchanged.